Example 1 from the substitution and elimination for nonlinear systems. We have the two nonlinear equations, or system of nonlinear equations. This one at least is nonlinear. This one actually is linear. And we want to solve for what x and y can possibly be if there is a solution. So first off, I'm going to color code the equation. So the first one will be color coded red and the second one will be color coded blue. And there's different types of methods to solving these, but for this one I will use substitution. So I'm going to take this second equation and solve it for a single variable. I could do it up here, but this one is easier. I can see that it's easiest to solve for y since I can just add x to both sides. So from this equation right here, we have y is equal to x minus 4, adding this x to both sides. Next, to use substitution, we need to take this variable that we solved for in this other one equation and substitute it for the y, that variable we solved for in this equation, into this equation up here. So since we solved for y, I'm going to substitute this equation x minus 4 into the y's up here and here. So, doing that on another page, we have x squared minus 11x plus 2 times our y squared, and our y from the other equation was x minus 4, and then minus 3y, and our y was again x, and this was squared, it's y squared, and then negative 3 times y, which was x minus 4, is equal to negative 31. So that's substituting our y equals x minus 4 from the other equation, as you can see. We've now substituted into the y's. So now we need to distribute and simplify and expand it as much as we can. So we have x squared minus 11x plus 2 times x minus 4 squared. So we need to expand this x minus 4 squared first. So we x minus 4 times x minus 4. And then minus 3 times x minus 4 is negative 3x plus 12 is equal to negative 31. So we have x squared minus 11x. We're going to distribute this x minus 4 times x minus 4 first before we multiply the 2. So I'm going to keep the 2 like this. So we have x times x, which is x squared, in that first distribution. And we have x times negative 4, which is negative 4x. And we have negative 4 times x, which is negative 4x. Then we have this negative 4 times negative 4, which is positive 16. Minus 3x plus 12 is equal to negative 31. So, again, we have x squared minus 11x. These two terms can be put together, so we have 2 times x squared minus 8x plus 16. Adding this negative 4x plus negative 4x, we get negative 8x. Minus 3x plus 12 is equal to negative 31. And now we can finally distribute this 2. So we have x squared minus 11x plus 2x squared minus 16x plus 32 minus 3x plus 12 equals negative 31. Simply multiplied this 2 all over, and we got this. Alright, so I notice that we have an x squared term here and an x squared term here. So x squared plus 2x squared is 3x squared. Next we have this negative 11x, this negative 16x, and this negative 3x. Adding all those, we get negative 30x. And then we have 32 plus 12, which is positive 44, is equal to negative 31. And we can actually add this negative 31 to both sides so that this side is equal to 0. And we will get 3x squared minus 30x plus 75 is equal to 0. So moving out to the next page, we have 3x squared minus 30x plus 75 is equal to 0, and we want to factor this as much as we can. we noticed there's a 3 here, a factor of 3 here, and that 30 is divisible by 3, and so is 75. So we're going to take out a 3. So 3 times x squared. 30 divided by 3 is 10. Negative 10 because it was a negative 30. And then 75 divided by 3 is positive 25. It's equal to 0. We can now factor this x squared minus 10x plus 25. So 25 is 5 times 5. But we see this is negative, so we know that negative 5 is going to be what we have, because negative 5 times negative 5 is also 25. So this factor is x times x minus 5. And this 3 really doesn't matter, because if we divide each side by 3, then it will just be 0 over here. So we have solution of x minus 5 is equal to 0 and x minus 5 is equal to 0. Well, that just gives us one solution of x is equal to positive 5. So now that we've solved for our x, we have x is equal to our positive 5. We need to go back to our equation here. And we remember we solved for y, we need to find out what our y is. So we can simply substitute what our x was, our x is 5, into our equation for y to get our y. So we have y is equal to our x, which is 5. I'll write that in red. Minus 4. So our y is equal to 1, which means that we have a solution where x was 5 and our y is 1.